All right, so we've looked at translations, vertical translations, horizontal translations, that's shifting of your graph. The V shape did not change. So what happens if you have a stretch and a compression? So we're going to look at vertical stretches and compressions. I am going to show you guys a quick little visual of some stretches and compressions. All right, so taking a look at vertical and horizontal compressions, here's our absolute value function. G of x equals, if you notice, there's a 1 out front, 1 times the absolute value of x. So that is our a value. If our a value is 1, that's still just the parent function, because 1 times the absolute value of x is just the absolute value of x. But I have a little slider over here. What happens if we change the 1? Let's say we make the 1 bigger. So if we make the 1 bigger, this is considered a vertical stretch. And you can see g of x, as I go to, let's see, a equals 2, it stretched it vertically. It made it more narrow. So a vertical stretch is going to narrow your graph. That will happen with any a value that is bigger than 1. So as I continue to get bigger a values, it just gets more narrow. All right, let's go back to a equals 1. Oops. Right. Ooh, it's a little touchy. Okay, so there we're back to a equals 1. What if a is less than 1? So I'm going to move this to the left. Let's get some values smaller than 1. So there's a 0.9, 0.8, 0.7, 0.4. That is going to be a vertical compression. So if your a value is less than 1, but we're still greater than 0, so let's just take note of that. That is going to compress your graph, and it will widen that V shape. So you can see g of x, the red V, has gotten quite a bit wider than the parent function, the blue one. All right, so if we keep going, we let a equal 0. Well, 0 times the absolute value of x is 0. Now we just have a constant. It's a linear function. It's not an absolute value function anymore. But what if we get a negative a value? So if I just keep going to the left and I have the a value negative, we've got a negative 0.4, negative 0.8, negative 1. That is what we call a reflection. It reflected across the x-axis. Our v in the parent function is opening up right here. If your a value is negative, it's going to open down because it has reflected across the x-axis. And if I make that a value, if I keep going beyond negative 1, you can see it is stretching. It's a vertical stretch. It's making our graph narrower. If I go back to a as a negative 1 and I slide this to the right, between 0 and negative 1, now we're getting compression. We're getting a V that is wider. All right, so we just saw in that video kind of how it works. Compare the graphs of g of x equals 1/2 times the absolute value of x. So our a value is 1/2. What we just saw in the video, if your a value is between 0 and 1, that is going to be a horizontal compression. It's going to widen the graph. So here you can see our graph got wider. If you have g of x equals -4 times the absolute value of x, our a value is -4. So two things are happening. There's a reflection across the x-axis, so we have a reflection, and the 4 is stretching our graph. It's a vertical stretch. So you can see that our red function down here, the g of x, got reflected across the x-axis. Now it's opening down, and then it stretched vertically, which is making it more narrow than our parent function. So compare the graph of each function with the function of f of x equals the absolute value of x. So we don't see the graph of the function, but we are able to describe the graph of the function based on knowledge that we're gaining right now. So we look at this, we say, all right, it's an absolute value function, so I know it's a V shape, and there's a 3 out front. So our a value is equal to 3. Now when your a value is equal to 3, that is going to be a vertical stretch. And then the vertical stretch is going to make your graph narrower than f of x. which is the parent function. All right, g of x over here equals a negative 1/3 times the absolute value of x. So what do we notice? It's an absolute value function, so it's going to be a v shape. And our a value is negative 1/3. So this tells us two things. The fact that it's negative means that there's a reflection across the x-axis. That also means that our v is going to open down. Because that number is between, if I took away the negative, because that's our reflection, and I'm looking at the 1/3, that's between 0 and 1, so that's going to be a vertical compression. And a vertical compression is going to make the v wider than f of x. So it's kind of cool. As we learn more about what the extra numbers represent and mean in our functions, we can say a lot about what this looks like before we even graph it.